But we'll start with the front page. So number one, you guys already know, and you have those answers. Number two, there are technically 6 equations, the big ones, and guys, you have to know this. Like, you cannot go without this. It should be programmed into your calculator. Like, have it everywhere. Okay, Celsius to Fahrenheit and Fahrenheit to Celsius. Which one is normally a bigger number?
Celsius.
Fahrenheit.
Fahrenheit. So that one's going to be 9/5. This one's going to be 5/9. Now we have C and F. And what's the other number? What's the freezing point in Fahrenheit?
32.
32. Some of you put 37. Some of you put 45. It's 32. So if we add 32 there, we subtract 32 inside. What's Celsius to Kelvin? So the number is 273. Is it minus or plus? Minus. Celsius is allowed to have negative numbers. Kelvin is not. Okay. So that is that. Number 3, 2, 6, 10, 14. Number 4, if you need help with that, from the student hours, we've been over it. Okay. Number 5, the hint is the mass number is the protons plus neutrons. Some of you got 6.9. It is 3 plus 5, which is 8 for lithium. Okay. So mass number is protons plus neutrons. For the most neutral atom, number of protons will equal the number of electrons, which will equal the atomic number. So 3 of those columns are exactly the same. The mass number is proton plus neutron. Okay. 6, most of you got right, and 7, we're back to significant digits. Okay, no decimal point. So does this 0 count?
No.
No. So this is 3. 1, 2, 3. This one got many of you. Some of you because you couldn't count. Others of you because are your ears cold?
No.
Oh, okay. When you have the decimal point, we do count trailing zeros. So this is 1, 2, 3, 4, 5, 6. Okay. Decimal point means you count them. No decimal point means you do not. Okay. 0.03002. Always count zeros in between. Never count leading zeros. So this is 4. Okay. 42.0, most of you got that was 3. Since there's a decimal point, we count as 0. Taking notes? Yeah. So this was last year's midterm. So like if you copy these notes down and like really understand this stuff, then you will do fine on the midterm. Which is in January. So like, yeah, now's the time.
Oh, we're that ahead.
Yeah, we're like way far ahead. It's awesome. Because I didn't waste a month on, well, significant digits. And what are we struggling with? Significant digits, of course. All right, so we have 20,000 with a decimal point. So do we count these? Yes. Yes, because the decimal point is there. Decimal point, you count them. No decimal point, ignore. Okay, so 1, 2, 3, 4, 5. Okay, next 924.21. Most of you got that. There's 5 non-zero digits, so it's fine. The weird parts are the zeros. Always count trailing zeros if you have decimal. Never count them if you do not. Okay, moving on like a cow would move on. Next page. I stole that joke from Christian. Okay, what's the percent error? What's the formula? Absolute value measured minus actual over actual. Okay. Absolute value measured minus actual over actual. A lot of you guys just did over 2. That's wrong. Okay. Measured minus actual over actual. Okay.
I think I did that.
So it's 3%. So if your answer was not 3%, then it's wrong. So you have 10.3 minus 10. That's 0.3 over 10 is 3%. Yeah.
So what are the lines in the problem?
Absolute value.
Oh,
I still have one.
So it makes a negative number positive. Number 9. This one's hard, NO3 minus 1. Okay, so nitrogen has how many valence electrons? Well, look at your periodic table, you all have one.
4.
No, I thought it
Yeah,
was
it's
5.
5.
Yeah, it's 5.
I have no clue. I'll buy 5.
It's 5.
8, 7.
What? You okay?
No, yeah, it's
Sure? Okay. So 1, 2, 3, 4, 5. Oxygen has 6.
I think it has 4. I don't
Carbon has 4. Okay, so now what? Well, I know I get to throw in 1 extra electron. You good?
Yeah.
So I'll throw it in there. So that's my minus 1. Now I'm stuck, right? Because these oxygens don't have a full octet. So we'll borrow from these two. And since we have 2 electrons, we can make a full bond. But we have the issue. Where's our life issue?
One of them needs to be double bonded.
One of them needs to be double bonded.
Right.
Oh, I got all of them double bonded and you said that was correct.
All of them double bonded is definitely wrong.
What? That's weird.
So nitrogen is unhappy because it only has 6. So it needs 1 double bond. So I don't care which one you do, but oxygen is going to contribute 2 of these and double bond here. The elements that will allow like just 3 coming off of it, or like a 6-tet rule where it only wants 6, usually boron. Okay. All right. You got 3 points. Congratulations. Doesn't happen often.
I'll take it.
Actually, it does. Probably once a chemistry test. Usually miss something. Okay. So that's that guy. You have to look at each one of them and say, does it have 8 electrons? And that's why we had to do the double bond. If you do all of them double bonded, then nitrogen has 6 times 2, which is 12, which is a little bit too many. Okay. Phosphate. Phosphorus has how many?
5.
Oxygen. There's 4 oxygens. Okay, now we're going to add these 3 electrons and connect the dots. Here, since we have 2 electrons, we can make this bond there. If you didn't put the little brackets, you lost a point. Okay, so that was all from our last test. Identify them. So I gave you the list here that you could use on future pages for your periodic table. So like if you made up names for this problem, the list was here. So be crafty. Chemistry is hard to do where you're like, I don't give you most of the answers already somewhere else in the test. So the answers pretend alkali, alkaline earth, non-metal, halogen, noble gas.
How's fluorine?
How's what?
I don't get how fluorine is.
Because halogens are the last column before the noble gases.
Oh, yeah, you're right.
Yep. Okay. Number 11. Largest atomic radius is all the way to the left. It's weird, but it is. So that's potassium. Smallest first ionization. To make it an ion, you want to drop 1 electron off. Potassium wants to lose that electron. Many of you just picked the wrong row and then did random things. So this is the fourth row, which has potassium as the first one. You have bromine as the highest electronegativity, right? Because it has the most electrons, the valence electrons. Electrical semiconductors, I would accept germanium or arsenic. They're both metalloids. And then krypton is one of the least reactive because it's a noble gas. Yes?
What was the third one?
Bromine. Bromine, because it wants one electron and then it's set.
How
Okay. Yes?
do you find the first ionization answer?
It's the one that has one valence electron because it wants to get rid of it. So that's always the first column. Largest atomic radius, always the first column. Highest electronegativity is going to be the halogens. Electrical semiconductors and metalloids. Got it?
Wait, that doesn't make sense. So
Which one?
all of them.
Okay.
Like, is there like a specific?
A and
Wait,
B
it
are,
says in the fourth row. Oh,
Yeah.
how did I? Okay, that makes sense.
What is C? What was C again?
bromine, always a halogen.
But 7. Oh.
All right, covalent compounds. Remember, covalent ones are ones where, when you're naming them, use the Greek prefix. So your name should include the Greek prefix for the number of atoms of each of them. And you drop so you have your two elements. You put the prefixes in there because they're prefix, they go before. And you drop the ending and add IDE. That's how you do covalent naming. So N2O3 is dinitrogen because there is nitrogen and oxygen. You have two of these, so dinitrogen. You have three oxygen. Tri-oxygen, but you drop the N, and dinitrogen trioxide. Okay? So I told you they're covalent, so you know you can do this because of that. I know, naming's hard. Yes?
I put dinitrogen, and that's it. Is that all of it wrong with those? Or like, why isn't that happening?
Because that's not the name. Because the name is dinitrogen trioxide. Okay, P4O6. So P is phosphorus. O is oxygen. 6 is hexa. And 4 is tetra. Then you drop the N. Okay, these are not going away. Unless you. Okay, Cl2O7. Cl is chlorine. O is oxygen. 7 is
This one's starting.
septa. 2 chlorine, dichlorine. Okay. You have also some named out, so it gives you an idea of what it should look like on the right side. Disulfur, so we have sulfur, but we have disulfur, so there's two of them. Dichloride, 2 chlorines. So it's giving you the element, it's giving you how many. Remember, a lot of you guys started throwing oxygens in everywhere and trying to make them polyatomic ions. Only if it has the 8 or the ite ending does it have oxygens attached. Okay? These are your polyatomic ions. If it's IDE, then don't assume that there's random oxygens. Okay? Dinitrogen, so nitrogen. Dinitrogen would be 2 of them. Pentasulfide, so sulfide would be sulfur. Penta would be 5. Your finger. So I know ide and ite sound similar, but they're obviously written differently. So you have 8 or I, you're not throwing random oxygens in there. All right, the ionic compounds, how do we do ionic? Do you have a question? Okay. So for ionic, we have the first element, second element, and then drop the N and IDE. Ionic is special because you know what the charge is on each one. So you don't have to like put the numbers in there because it's already assumed what the numbers are. So Na is sodium. You have your periodic table, so if you forget the name, look it up. Don't be like, and make up an element name. Okay. I is iodine. Okay. So this will become sodium iodide.
How do you say dichloride?
Dichlorine septoxide.
Oh, okay.
Okay. How do I know this works out like this? Because sodium never takes any charge but what? What is the only charge that sodium takes? It's in the first column, so it takes a +1. What does iodine always take? It's in the last column, so it's -1. So these work perfectly together to make NaI. Next, we have CaO. Ca is calcium. O is okay. For oxygen, we drop the ending and put IDE.
So you do monoxide.
Nope, because it's not covalent. So for ionic, we already know the combination because calcium is +2 and oxygen is -2. I know exactly how many I need. It's one of each. If it was covalent, we would have to because there's an infinite number of ways to combine. Okay. LiCl. Li is lithium. Cl is chlorine. Take off that ene and add IDE. Lithium chloride. Hg is mercury. S is sulfur. Chop the ending. Add IDE.
How do you know what the ending is?
Always IDE for covalent and
No,
ionic.
Sulfur, like.
You practice. Sulfide, oxide, iodide, chloride. Yeah. It's usually like what sounds normal. So like chloride is weird, and chlorinide is weird. Chloride, but yeah. Like
It's only
if you
normal
have
because we see it.
solide, you're like, I've never heard of solide. Suide, side, sol, for sulfuide, sulfuide. Sulfuride would be good, but you didn't drop any of it, so there you go.
Sulfuride.
So I would just kind of guess at it, but still, you're dropping the end and writing it. Okay, next, cobalt sulfide. CO is cobalt. Sulfur is S, and add IDE. Okay, questions on those? That's the easy way, writing from the name to the, actually no, I think this is the hard way, and then writing name to formula is
Name to formula.
yeah, but I didn't give you any other ones with the weird, where you have to put the charge.
These ones just take more time.
Okay, calcium phosphide. Ca is calcium, phosphide, phosphorus. Done. Or am I?
Cap.
What's the charge on calcium? +2. What's the charge on phosphorus? -3. You're right. This way starting. So you need 3 of these, 2 of those.
Oh, got it.
So that it equals a 0 charge. Okay. Potassium. Okay. What is the charge on potassium? +1. What's chlorine? -1. So ACl. Okay. Going on you next. Iron 3 oxide. What's the charge on iron? Dylan.
What? OH?
Iron 3 oxide. What's the charge on iron? Or on 13.
Oh.
Iron 3 oxide.
In charge?
Iron 3
The charge. What's the
oxide.
charge?
Oh, the cluster.
Oh, cool. They tell us in the problem. And oxygen is always -2. So how do I combine these? I need 2 irons, 3 oxygen. Why? Because if I multiply this by 2, I get +6. If I multiply this by 3, I get -6. And they equal out. Okay. Lead 2 chloride. Esteban. What's the charge on lead? Lead 2 chloride.
2.
Thank you. What's the charge on chlorine? Andrew.
What number is that?
13.
They're like what? Where?
1300
Lead
3 oxide.
2 chloride.
I got it wrong. I don't know.
I know, but I need the charge on chlorine. You know this. Don't look at your test. Look at your
Okay,
periodic
so
table.
I like completely spaced out.
Okay. So look at your periodic table
Okay,
and find chlorine. Okay, what's the charge?
Negative. I don't know.
-1. Yeah, because you want one column back from the noble gas.
Right.
So if lead is +2 and chlorine is -1, then it's lead chlorine. Lead 2 chloride. You have 2 of these because you need -2 to balance the +2. Okay, last one. Barium chloride. Barium carries a what charge?
+2.
Barium is a metal, so +2. Chlorine carries a -1. So I need 1 of these per 2 of these. So this is like combining a lot of what we've already learned to name these things or undo the names. Questions on ionic or covalent naming? So, what's your question?
How do we find them?
Okay, so let's take iron 3 oxide. So iron, you have to find the symbol for that. So if you don't know it, you look through your periodic table, find iron, it's Fe. When they give you the number, that gives you the charge. If they give you no number, you are expected to know the charge. So how do we find the charge? Anything in the first column is plus
+1.
+1. So if you're looking at your periodic table right now, the first column is +1. So that would be all the elements in the first column, including hydrogen. And that's the only one I have memorized.
Question. Oh, sorry.
Periodic table. I'm not done yet. Sorry. So hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium all have a +1 charge. They will never have any other charge than +1. There's always +1. Column 2, beryllium, magnesium, calcium, strontium, barium, and radium have a +2 charge. Always. I never say always, so that's like meaningful. Okay? First column, +1. Second column, +2. All the columns in between, who knows? They can take any number of charges, which is why they give you the charge for iron and they give you the charge for lead, because the transition and post post-transition metals do their own thing. Okay, it is confusing. So that's how they give you that charge. Now, the nonmetals you count back from the other side. So noble gases have a charge of 0. I'll get to it. The halogens, which is the second to last column, so that's your chlorine, fluorine, iodine, bromium, those have a -1 charge. You go back one more, and that's a -2 charge, so that's the column with oxygen. Go back one more, that's a -3 charge, that should be the column with nitrogen. -4 charge, carbon. So that's how you know these charges that I made up. Yes?
So what is the -4 then? Why is it +2?
Because it's a post-transition metal, and so you can't, it doesn't work for that. It only works for the non-metals where you count backwards. So always metals will have a plus charge. Okay? Non-metals will have a negative charge every single time. What makes something a metal? It has a positive charge. Positively charged ion. Good question. So how do we figure out how they match now? You take the charges, you go, how do I make this 0? I need 3 of these and 2 of those. That equals 0. You got this. How do I make these charges 0? I need 1 of these and 1 of these. How do I make this 0? I need 2 of these, 3 of these. It's like your least common multiple in math. It's basically what you're doing. Okay? If I have +2 and -1, I need 2 of these to balance out that one. And so on. Yes, Andrew.
I forgot. Completely forgot that question.
Okay, Ryan.
Says boron and aluminum, like -5 charge.
Boron is a metalloid, so we don't know.
We don't
So
know.
it could either be -5 or +3.
So it would give
And
us
then-
the charge of those two if it was in one of the
And then
problems.
how about carbon and silicon? We don't know those
We
either.
know carbon.
Yeah.
Carbon's a non-metal. So how many columns back is it?
So 4. So it's -4. Okay.
Yep.
So I guess doesn't work for these guys in the middle.
Yep. Okay. So that is that. Next page. If you didn't spend time memorizing your polyatomic ions, you had no hope. I mean, we have hope in Christ Jesus, but we just don't have hope. Like, the polyatomic ions are the ones that you have to memorize, or you're not going to. You can kind of guess. So NO3 minus is nitrate. OH minus is hydroxide. These are on your flashcards. ClO4 minus is perchlorate. Phosphate is PO4 3 minus. You can figure that out from elsewhere on the test. In fact, I gave you